standard 32 is talking about composition of functions, which you've done this in Algebra 2. We're just going to do more with the domain now than you probably did in Algebra 2. So this right here, what do you think that says? F of g. That's not fog with a really little o, okay? That means F of g. It's the same as that. They're both F of g of x, okay? So just so you know, that notation means the exact same thing. We will get to talking about the domain once we do the composition as well. It's just a little more to think about. So let's go through the first example here. I'm asking you to find F of g of x and g of f of x, and then state the domain for both. So let's go through F of g of x first. Now guys, when you're doing these, please label for me what you're doing. Don't just start doing a bunch of substituting in without telling me if it's F of g of x or g of f of x. Okay, your notation matters. So what does it mean to do F of g of x? Do you guys know? Okay. Yes, yeah, take the g of x function and substitute it in. So this whole x minus 4 is going in everywhere there's an x in the other function. So we have the quantity x minus 4 squared plus 2 times x minus 4. All right, x minus 4 quantity squared, is that just x squared plus 16? No, what is it? You guys are really quiet suddenly. X squared. Good. And then I can distribute my 2, so plus 2x minus 8. So when we simplify, what do we end up with here? X squared minus 6x plus what? 8. Good. All right, so that is f of g of x. Nope. You're just done. Factoring is actually not simplified form. Simplified is usually more funny. Okay. All right, we also have to think about the domain of this one. Okay, so the only tricky part with domain is that you have to begin with any restrictions on the original function you plugged in. So guys, what was the inside function this time? X minus 4, the g of x, right? So if I think about the domain of g of x, this x minus 4 over here, are there any restrictions on that? Meaning, ask yourself the two questions. Is there a fraction? No. Is there an even root? No. So what's the original domain of g of x? Negative infinity to infinity. Okay, so we start with that. Then we look at what we actually did the composition of. We got to this x squared minus 6x plus 8. Ask yourself again, is there a fraction? No. Is there an even root? No. So what's the domain of this? Yes. Okay. Domain will obviously get more complicated than just negative infinity to infinity every time, but we'll start there. All right, let's do g of f of x. So which one is the inside function this time? F of x, right? Okay. So I am now taking this whole thing and plugging it in. So I'm going to have x squared plus 2x minus 4. Is there anything it needs to do to that? No. Okay, so we're done with the first part. Now I need domain. Okay, again, what's the inside function? F of x. So look at f of x originally. Were there fractions or even roots in it?
No.
No, so no restrictions to worry about there. And then look at our composition at the end. Any fractions or even roots? Nope, so what's the domain? Okay. we're starting easy to make sure you get the process down. Are we okay so far? Okay. Let's go to number 2. All right, same thing, f of g of x, g of f of x in the domain. So let's start with f of g of x. All right, so I have fractions to deal with here. So I'm going to plug x squared minus 1 into both numerator and denominator. So I get x squared minus 1 over x squared minus 1 minus 1. So what's my fraction simplify to? Don't overthink it, guys. X squared minus 1 over... That's it. You could factor the numerator, but is that going to do anything for you as far as reducing anything? No. Oh, and can we cross out the x squared? No. Okay, good. I'm sure we know that. All right, domain. We probably have more to think about now. So what was the inside function? G of x. So looking at g of x, fractions or even roots? Nope, so no restrictions to worry about there. But look at our final answer. Do we have a fraction this time? Yes. Okay, so when we're dealing with that, I know that x squared minus 2 cannot equal 0. What does that mean x cannot equal? Plus or minus root 2. Yeah, right? We'd add the 2. So how do I write my domain in interval notation then? Perfect. Negative infinity to negative root 2. Negative root 2 to root 2. It's easy to forget that middle section, so don't do that. And then root 2 to infinity. So you're just jumping over those two values. Okay? All right, now we have to do g of f of x. So now I am taking this whole fraction and plugging that in over here. So I have the fraction x over x minus 1 squared, and then minus 1. So we have some simplifying to do. All right, so when you square a fraction, you're squaring numerator and denominator. So numerator is going to just be x squared. What is that denominator going to turn into? Go ahead, Katie. What? Yes, x squared minus 2x plus 1. And then I still have this minus 1 over here. That doesn't look very simplified, does it? I need to combine that minus 1 with it. So how do I subtract when I have a fraction? What do I need? Common denominator. So again, I'm going to write it just to make sure you guys can see it. I have to take numerator and denominator by x squared, multiplied by x squared minus 2x plus 1. Okay guys, so we have to be careful here, because what is happening with all of this? So do you guys see like every sign is going to change over here? Okay. Can we simplify it all in one step? What is x squared minus x squared going to be? Okay, that's gone. And then distributing the negative through the rest of it, what do I have? A 2x and a minus 1? Yes, okay. right, that is your simplified g of f. Okay, domain. Give me a second, make sure everybody's there. All right, which function was on the inside this time? F of x. So look at original f of x. Fractions or roots to worry about? Yeah, fractions. So right away, what do I know that x cannot equal? 1. Okay, so I know I have to kind of side note over here, x cannot equal 1. Then I have to look at my final answer and see if there are any additional restrictions. So again, all we care about is the denominator. You can factor it or go back to what it was before you multiplied it out, right? What can x not equal based on that denominator? Do you guys understand what this is, factor? Isn't it back to what we started with here? Okay, so still x could not equal 1, right? Okay, so that's your only restriction. So you just have to say negative infinity to 1, 1 to infinity. There will definitely be times where you start with an original restriction and then it changes by the time you get to your answer. So they both play into your domain. Okay? We okay so far? All right, let's look at 3. All right, let's do f of g of x first. We got a lot of fractions now. Okay, so just plugging it in looks kind of ugly, and taking this fraction and plugging it in both numerator and denominator. So I'm going to have x over 2x minus 1 minus 2 over x over 2x minus 1 minus 1. Everybody okay with just step 1 of plugging it in? What do you think we need to do from here? Common denominator. So it's the same thing all over the place, right? All right, so I'm going to write it out, distributing, and then we'll deal with combining like terms, just to make sure we're okay. So the first numerator, I have an x. And then do you guys see how it's going to become minus 4x plus 2 over 2x minus 1? We're okay there. And then down in your second numerator, at the bottom, you're going to have x minus 2x plus 1 over 2x minus 1. Just want to make sure we're all to that point. There's more to do, but I just want to make sure we're all on the same page here. Did I lose you? Victoria, you're making a face. Are you sure? Okay. If you're getting lost anywhere in this, please ask, what's happening somewhere, because I know there's a lot of levels to our fractions. Wait a second, make sure everybody's with me. Yeah. Okay. All right, we okay? So I definitely need to combine like terms. And then when it's a fraction divided by a fraction, what does that mean to do? Multiply by the reciprocal. Do you guys see what's going to cancel out when I do that? Do you see how the 2x minus 1 and the 2x minus 1 are going to go away? I'm fine with you not rewriting all of this flipped, just so you can cross that out. So if you see it from here, definitely just go, all right, these are going to be gone. And then I can simplify, what's x minus 4x? Negative 3x plus 2 over, what's x minus 2x? Negative x plus 1. You okay with that fraction? It's not hard, it's just kind of messy. Okay, then we have domain to think about. So let's go all the way back up to the top. All right, which one was on the inside this time? G of x. So I have to go look over here at this g of x function. It's a fraction, right? Look at it. What can x not equal? 1/2. So little side note for me, I know x cannot equal 1/2. Then look at my final answer. Is there something else x cannot equal? 1 or negative 1?
Negative 1.
Positive 1, right? Okay. So, how do I write my answer? Negative infinity to, you just have to know the order of 1/2 and 1, right? 1/2, good. Union. 1/2 to 1, don't forget that middle part, union. 1 to infinity, okay. So does that make sense how the original function matters in writing your final domain? It's always the inside one that changes it. Okay, I want you guys to try g of f of x on this one. See if you can do it. I'll give you a minute here. Once you get your fraction done, check with your neighbors, see if you guys agree. right, did you get to x minus 2 over x minus 3? Okay, good. What'd you guys tell me for domain? There's two things x cannot equal, right? What are those two things? 1 and 3. So domain should be negative infinity to 1, 1 to 3, 3 to infinity. How'd we do? Yeah? Questions? Colin, can you see? Okay. Did you guys get it in the back? Anybody issues before we move on? We're doing all right with multi-level fractions. Yes, okay. And we're all okay with why 1 is not included? We get which fraction we look at first? Okay. All right, turn the page. Okay, guys, let's look. Now instead of fractions, we're throwing a square root in there for you, okay? So let's do f of g of x together. All right, so I am plugging the square root into something squared. It does. So it becomes just x plus 1. This is where domain is, you just have to pay attention. If all you looked at was the final composition of f of g of x, it looks like the domain should be all real numbers, right? But should it? No, because what do we have to start with? We got to start with this guy, right? So I have to start with x plus 1 has to be greater than or equal to 0. Do you guys see why we practice domain a lot before getting to this? Yes. All right, so what does x have to be greater than or equal to? Negative 1. So, bracket, negative 1 to infinity. That is your actual domain. Okay. Let's do g of f of x. Okay, so I have the square root of x squared plus 1. Everybody okay with the first plugging in there? Okay, is that? No, okay, good. We cannot take square roots of pieces. Is there anything I can do to simplify that? You cannot, like, that's it, that's the answer. Ooh, don't erase it. All right, so that is the composition. Now we have to think about domain. Okay, so which one do I look at initially? F of x. It was x squared. Is there anything I need to worry about there? No, okay. My answer has a square root in it. Okay, so what do we worry about with square roots? Yeah, because we can't take the square root of a negative number, right? So you can try to do this algebraically and set it up x squared plus 1 has to be greater than or equal to 0. Or let's just think about it a little. When I plug something in and square it, no matter what I've plugged in, what kind of number do I get? A positive number, and then I'm adding 1 to it. Is there any way that's ever going to be negative? No. So what is my domain? Okay. So a little bit of thinking there. Questions on any of the first 4 examples? Because number 5 is clearly different. Yes. So let's think if I plugged, what if I plug like -5 in? What is that? Is that okay? Yeah. There's no way to make what's under here negative. So that means there's no restrictions on the domain. It can include everything, okay? Which is weird for a square root, but because we're adding and it was squared, everything works. Okay. All right. Okay, let's look at 5. Very different type of question here. Okay, so first I'm just giving you the function f of x. It's just a relation of these 4 points, okay? So domain, this should be easy. Don't overthink it. What is the domain? Perfect, -2, 1, 3, 4. Squiggly brackets, right? No parentheses. Yes, okay. What about the range of this one? 1, 0, 2, 7. And if you put them in order, that's great. Doesn't matter to me. Either way is fine. Okay, g of x, same thing here. What's the domain? -2, 5, 4, 0. Range. 3, 1, -2, 4. Okay, that review, you already knew how to do that. All right, now is where it looks different. Now I'm actually asking you to add together the two functions f of x and g of x. So the only way you can add functions together is when their domain values overlap. So like if they have the same input, you can then add the outputs. You guys remember way back whenever you first learned functions and you had like the function machine and the input and the output? You guys, yes? Okay. So if I look, first domain value here is a -2. Is there also an input of -2 in the second one? Yes. Okay, so I can use the -2 and then I'm adding the output. So what is 1 plus 3? 4. Good job. So that's your first point. We're going to like make a list of these points. So -2, that does not look like a 4. That's my first point in f plus g of x. So then I move on to the second point. The x value is a 1. Do I have a 1 as an x value in the second one? No, so I don't get to use that point. What about the next one? Input of 3. Do I get to use that one? No. What about the next one? Yeah, I can use those two, right? So when x is 4, what do I get for my y value? 5. All right, so what is the domain of my new function? -2, 4. And what is the range? 4 and 5. Okay. Hopefully it makes sense to you that the new domain here is -2 and 4 because those are the only two that actually matched from these two domains. Okay. All right, so we're doing the same thing here, but now we're subtracting. So what do you think we're going to use as far as points? Like, is it going to change the points that I'm looking at? No. So all 4 of those, adding, subtracting, multiplying, dividing, you're using the same 2 points out of your 2 functions here. So what's going to be true about the domain for all of those? Going to stay the same. All right, now order matters here because we are doing f minus g. So when I get an x value of -2, what does my y value end up being? -2, good. X value of 4, what's my y value? 9. So domain is still negative 2, 4. Range is now negative 2, 9. That's a 9. Okay, we multiply in the next one. So when x is negative 2, what do I get for my y? 3, right? When x is 4, what do I get? Negative 14. Same domain. Range is now 3, negative 14. Okay, and then dividing, when x is negative 2, what's y? 1/3. When x is 4, what's y? Negative 7/2. Can you think of a time where that division 1 might cause us problems? Like something you might need to pay attention to? Yeah, if you have a 0. If I do f over g and I end up with like 7/0, do you think we can include that point? No. Okay, so it just doesn't get included in your outcome. So domain is the same. Range 1/3, negative 7/2. Okay, so the actual operations on the functions, are those pretty straightforward and simple? Okay. Do you see how the last two are different? All right, those are composition of functions. So the first one here, f of g of x. I start with g of x on the inside, right? So let me show you what this means. So I have to start with the g of x function. My first input is a negative 2, and that gives me an output of 3, right? I then take that output. Is that an input on the other function? Is there a 3 as an input? Yes? And what do I get as the output there? 2. So my first point on the composition here is negative 2, 2. Do that again, okay? All right, so I go to the second point in g of x. 5 gives me 1. Does 1 give me something in the other function? Yeah, what does 1 give me? So what's my point? Not literally what's my point, but what's the point? 5, 0. You with me? Okay. Next, 4. What does 4 give me? Negative 2. Does negative 2 give me something? 1. So the point is 4, 1. Alright, last one. 0 gives me 4. 4 gives me 7. So 0, 7. Are you guys catching up? Okay. Just gotta think input, output. This gives me, what does it give me? Okay. Alright, I'll rewrite those. You guys try g of f of x. Oh, you can obviously do the domain and range here. How are we doing on this one, guys? Are you getting as many answers? No, good. Okay, good start. All right, I'm going to go through it. We start with the f of x now. Negative 2 gives me 1. 1 gives me nothing. 1 gives me 0. 0 gives me 4. So I've got 1, 4. 3 gives me 2. 2 gives me nothing. 4 gives me 7. 7 gives me nothing. So that's it. How'd you guys do on that one? Good, we get it? I know it's a different kind of looking at functions view than you guys have had before, so. Questions? All right, we'll stop there.